Okay, so this is question number 30 of the magnetic fields homework booklet. So in question number 30, we're given a diagram, this diagram down here, and what it shows is it shows the waveform that is obtained when the output of an alternator is connected to a cathode ray oscilloscope. So an alternator is essentially a coil of wire inside a magnetic field that spins. And so it generates an alternating EMF and therefore generates an alternating current. So if we look at this, just so we know what we're looking at when we come to look at these four traces down here, this thing has got an EMF of 1 square upwards, and it has a time period that goes of 1, 2, 3, 4, 5, 6 squares, because one cycle takes 6 squares to perform, basically. So we want to know which one of these traces best represents the output from this alternator when the speed of the rotation of the generator is doubled. And we're not going to change the oscilloscope at all. So we're not going to change the Y gain, and we're not going to change the time base. So when the speed of the rotation doubles, two things happens. First of all, the rate of change of flux linkage increases. Because this thing is now cutting through the magnetic field quicker. And if that happens, then the EMF increases. So therefore, compared to here, if we look at these traces, then the peak of this thing should go up, because the peak basically shows us the size of the EMF that's being induced. So if we look at A, the EMF is 1 square, so it can't be A. It could, however, be B, it could be C, or it could be D. So we've got rid of one of these things, but we're still left with 3. So we need to come up with another way of working out which one of these 3 is the correct one. Now, again, we go back to this. So the speed of the rotation of the generator is doubled. So if the speed of the rotation is doubled, then the frequency of the EMF that's induced, and therefore the frequency of the current, increases, because this thing is basically turning around quicker, and so it's cutting through the fields quicker. So the frequency increases, but we can actually be more specific than that. Because the speed of the rotation doubles, then the frequency also doubles. And if the frequency doubles, that means the time period decreases by a factor of 2. Now, if we go back to this diagram here, the time period was 6 squares. So what we want is a trace that has a bigger EMF, so B, C, or D, and it has a time period of only 3 squares. So if we look at B, one cycle goes from there to there, so that's 3 squares, so it should be B. But let's just check. So C is 1, 2, 3, 4, 5, 6. So that has the same frequency, and so that's not doubled, so it's not C. This one has a frequency of, a time period of 1, 2, 3, 4. So it's not that one either. So therefore it must be B. So that was question number 30 of the magnetic fields homework booklet.